everyone, I am Manu, and in this video we'll try to understand the concept of distance, speed and types of quantity. So let's begin. First of all, we'll try to understand the concept of distance. Distance means any path that is covered by any subject I am moving. I have covered two miles. So this is my distance. How path I have covered. How path I have covered. It is known as distance. So path, I think so. Okay, the part that is covered by a subject. Okay, it can be, we say it is in miles, it is in kilometers, but not in meter, because it is not a distance. Because we say distance is a large quantity, a magnitude. Yes, a magnitude. Okay, so distance, from distance we get our speed. Okay. Speed is mainly dependent on the distance and also on the time. So speed is a speed. Speed means that how much constant time, at what constant time I am moving. So I have given you the example earlier in the video that I have covered 2 miles. So how much time I taken to cover the 2 miles. So for example, 2 miles I have covered. In 2 hours. I have covered in 2 hours. So to find out the speed, how much constant, what is the constant time to cover at per hour, how much distance I am covering at 1 hour. To find out that, the formula to find out the speed is S is equals to distance over our time. Okay. And S means our speed, and distance means the path that I have covered, means 2 miles. And in which time? 2 hours. So I get 1. It means 1 hour. It means 1 hour. So I have covered 1 mile in 1 hour. So I have completed 2 miles in 2 hours. It's too simple. Okay, and after that, speed. Speed is we can count it any quantity. Yes, we can count it. So speed is scalar quantity. Okay, there are 2 types of quantity, scalar and vector. So scalar and vector. We say the scalar quantity is the quantity that only tell us not tell us about the direction, because speed is not telling about the direction. It's telling how much distance I am covering in a constant time. So scalar quantity are the quantities that tell us the magnitude. Magnitude means any very huge, the size of any object, okay, or important thing about the object. So we said it tells us about magnitude. Okay, there is no much space to write magnitude. So it tells us about a magnitude, a size, but not tell us the at what direction. So in earlier video, I'm saying video, not in this video, I tell you that I have covered 2 miles. So it's not telling at what direction I am going to north. I have got the 2 miles in north direction, in east direction, in south direction, or in west direction. So it not tell us about the direction. But vector quantity is some opposites to the scalar quantity. It tells us direction, but not only direction, it also tells us about the magnitude. And magnitude. Okay, so it tells us this. Scalar quantity tells us about the magnitude and not tells about the direction or any other thing. But our vector quantity tells us 2 things: direction of an object and magnitude. So example of scalar quantity is area. Okay, we say area of an object, mass of an object, and vector like we say velocity. Okay, velocity. Peculiarity of the scalar quantity. For example, this is a rectangle. We say this is a park. I have bought this park, and its area is 22 meters. Its area is 22 meters square. 22 meters square. Okay. So it's not telling at which direction this 22 meter square is it, but it only tells us about the magnitude. Means it is telling about any size, any what is in it, how much distance, how much thing in it, space in it. Okay, it is 22 meters square. Okay, it also tells us about the location of an object, but not tell about the direction. So this is what is this? This is our scalar quantity, not vector quantity. So example of vector quantity is velocity. 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 It is like the speed, but there is a difference that speed tells us how much distance we are covering in any constant time. So it tells us. It also tells us speed, but one thing also. Direction. And speed. Okay. So velocity tells us direction and speed. So we say that we get v from our direction plus speed. Okay. Direction plus speed. Okay, and the formula to find out the velocity is v. What is the meaning of this v? We are talking about mean velocity. It is a short form of say a symbol of velocity. So v is equals to displacement of time. Okay, how much time taken we have and displacement. What does this mean? What does this mean, displacement? Okay, so displacement means we say, for example, my drawing is too beautiful. This is my house, and this is your house. So there is a way to go to your house. So we go here and here, and then I come to your house. And there's another way. This is too long way. There are two ways. Or we may draw too much ways to go to your home. There are 4 ways. So if I will make, this is my house, and this is yours. So if I make this a straight line like this to my house, so this straight short line is known as displacement. Okay. Oh my God. So, if there is a change in velocity, what will happen? Anything exists? Yes. When change, velocity change, so we get acceleration. Yes, acceleration. Most of the people think that the acceleration is high speed of any motorbike or any vehicle. Okay, a high speed, but that is wrong. Yes, that is wrong. Okay. So, at what time the acceleration exists? First, there are three ways. Okay, 3 reasons. One is increase in velocity, and second is decrease in velocity, and third is change in direction. Okay, if I am going here and there's a change, there's a cut, so this is change in direction, and decrease in velocity or increase in velocity. Okay. For example, the example in our daily life of the acceleration is if I'm having a car like this. If I'm having a car and there's a person, he's driving the car in very high speed. Okay, and suddenly he applies brake, and its body go towards. This happens due to the acceleration. Okay, and same time, same car. Okay, wait a second. Yes, a person. Same person, his car is on the rest, okay, and he suddenly applied the accelerator, so it goes backward. this also happens due to acceleration. Yes. Or this is a person, and it's going. Okay. And there is a cut, a round cut, or is a chalk. So it moves. Okay, wait a second. We imagine that his speed is 2 meter per. Oh, wait a second. Second. Okay, 2 meter per second. So when it changes its direction. Oh, wait a second. This is our speed. This is wrong. To north. Oh, wait a second. North. Okay, so this is our velocity. So he is going in the north, and it opposite, it changes his direction. So it now is going in the west. So now there is acceleration, because this is a person, he is in a car and driving a car. So when it move, the car handle, it moves like this. So it would go here, opposite. Okay. So this is due to acceleration. Okay. To find out the acceleration is formula. A is equals to u minus v. Here u and v is, we say one is final position, and second is we say position not, is a speed, and there is the final and the first position before starting. So for example, this is a road, and this is a car. Okay, a person is in the car. So the speed of the car is 0 here, 0 kilometer. Oh, kilometer also. 0 meter per second, we say per second. And when it moves, here the car's speed is 10 meter per second. So the car stops here. So the final we will say velocity is 10, speed. Okay. So v minus 10 minus 0 is equals to 10. Now 10 is divided. How much time taken? We say I taken 2 seconds. So 2 divided by 2, same like formula. Okay, it is our time, and it is our minus after the subtraction. So 2 we get 5. So 5 is our answer. Okay, 5 is our acceleration, average acceleration. A is mean average acceleration. So there are 2 types of acceleration. Yes, one is negative, and second is a positive. Negative acceleration and positive acceleration. Okay, so when there is a decrease in velocity it is known as a negative acceleration. Mean D, we say de-acceleration, and in positive it is opposite to it. When there is a change, I'm saying change, not change, increase in velocity. So it is a positive velocity, velocity not positive acceleration. So thanks.